Good morning, everyone. I hope everybody is safe and thank you for coming to class. Could one person tell me if they can hear my voice and see my screen? Just one will do. And one person tell me if they can see my screen and hear my voice? Okay, thank you. And you can always, yes, I can. Okay, wonderful, wonderful. Good enough. Thanks. Okay. All right, guys. So the plan is we are here. We are working on 11.2a and 2b. We did some of the problems last class. So this section is kind of funny because it has two different topics. One topic was about polygons, convex polygon, concave polygons, and they're related to the topic that we will be discussing today, and we will be talking about symmetry. Okay, I'll spell the word and everything. So, what is the plan today? We'll talk about symmetry, which is part of 11.2. Maybe then do some of the problems from 11.2. And if you have questions from anything you've done in MATLAB or anywhere else within this course, feel free to ask anytime. All right, so let's see. These notes that I'm going to share with you are already on Blaze View in the notes folder. Okay, so let's go over here. Let's take this picture. So what is symmetry? Symmetry in English, it means balance. What kind of balance are we talking about? So if you have a shape and if you can, excuse me guys, I'm going to turn on my light and I'll be right back. Okay. So if you have a shape, for instance, the one on the left, if you can draw a straight line, okay, to the middle of the shape, I'm going to draw it like this, so that the left side of the shape is the mirror image. This is kind of important, guys. Mirror image of the left side is the mirror image of the right side, and the right side is the mirror image of the left side. Then we say this shape is symmetric. Now, there are different types of symmetries. This is called, we have two names for it, okay? Reflectional symmetry from the mirror image, reflectional, reflectional, and sometimes people also call it line symmetry or line symmetry. Once again, symmetry is about balance. In mathematics or geometry, we have multiple, actually two types of symmetries. Actually, there are more. We'll discuss only two. And you will be teaching some of these things, and you will be tested on your knowledge of some of these things when you take gaze. So symmetry is about balance, but what kind of balance? If you can draw a line right through the middle, it doesn't have to be vertical, so that the left side is the image of the right hand side. Or another way to say it, if you fold it along that line, the parts of the picture will match each other, will match like your left hand matches your right hand. Okay. Now, so this shape has reflectional symmetry, and you can draw this line only in one way. So how many lines of symmetry are here? One. Lines of symmetry. How many lines can you draw so that the left-hand side is same as the right-hand side, or the bottom is same as the top? Lines of, symmetry. We can say number of lines of symmetry. I would say one, only one. Okay. Again, if you have a question, if I'm saying something that doesn't make a lot of sense to you, or you have an example you want to share, unmute yourself and just ask. You don't have to raise your hand because I can barely see it. They put it in a little box in the corner. So don't be shy. So we're going to give you more examples. Okay. So I'm going to leave the text here. These are basic words: mirror image, symmetry. We are really talking about reflectional or line symmetry. That's really the main thing we are talking about right now. Let's bring another shape here. This shape. This shape has actually two lines of symmetry. You can do a vertical line. The left and right hand side will match. They will be mirror image of each other. And you can do a horizontal line too, and the top part will match the bottom part. So how many lines of symmetry does this shape have? The first question I can ask you, does it have reflectional symmetry or line symmetry? The answer is yes. How many lines of symmetry exist? Two. Let me show you one more picture, okay? These are all from your notes. Now take a look at this shape. Okay, I'm gonna actually bring both. I'm gonna just bring this shape. Take a look at this one. This shape has a vertical line of symmetry. The left and right side, they match. A horizontal line of symmetry, top and bottom match. A slant line of symmetry, actually two slant lines. This one, this portion matches this portion, and you draw another line here. The top left matches the bottom right. So this shape, the shape you're looking at, has four lines of symmetry. Of course, if it has lines of symmetry, we call it the shape has reflectional symmetry or line symmetry. I'm going to pause here just a little bit, see if you have any questions. These pictures are here, they're in your notes. These are examples of shapes that have lines of symmetry. And here, basically, what I'm saying is what I'm doing. So, determine the center. How do you determine? These are the steps. Determine the center of the shape. For my shape, will be roughly this point, this point. Determine the number of different lines that split the shape so that one half of the shape is the mirror image of the other half. Okay. And the number of lines determined in step two is the number of lines of reflection symmetry. How many times can you do it? How many ways can you cut it in two halves by a line so that one half matches the other half? You can say mirror image, or you can say when you fold it, it'll fold like your two palms. Okay, the thumb will match the thumb, the little finger will match the little finger, the middle finger will match the middle finger, so on and so forth. The ring finger, forefinger, so they nicely match. Again, it's a very elementary concept. It's not very difficult to follow, I think. All right, guys. So there's another type of symmetry. Okay. This type of symmetry right here, the recycling bin symbol. Well, what is that? Let's try to understand that first. We'll get there. This is not about mirror image. This is called something else. It's called rotational symmetry. This symmetry that we're going to be talking about has a different name. It's called rotational symmetry or point symmetry. Why is it called point symmetry or rotational symmetry? Take a look. On this shape, just a moment. Look at, so these, I just copy pasted them, right? There's no way you can draw a line that'll cut the shape into two equal, identical mirror image halves. It won't. If you fold it, it's not going to match. If you fold it like this, it still won't match. The left and right, bottom or top will never match. So this shape does not have a line symmetry or reflectional symmetry, but the shape has some kind of balance. It looks kind of nice. What kind of balance does the shape have? Let me see how I can do it nicely. Well, somehow it won't let me, but don't worry, I'm gonna do it in a different document. You'll understand what I mean. This is the original shape. Okay, this is the original shape. And I'm gonna take a copy of this. Okay, I'm gonna make it a little transparent. Let's see if I can do it. Okay, so guys, I'm not gonna worry about the whole transparency, but I hope you can understand. If anybody knows how to make it transparent on Word document, let me know. I'll fiddle with it just a little bit. Okay, there is a way you can make the shape somewhat transparent. Close up the artistic. There you go. Okay. Now, I put this on top of this. Okay. Again, this doesn't have a line symmetry, but it has some kind of balance. What's that balance? Well, if I rotate it like a wheel of a car, it falls onto itself. That's nice. So do you see that's why it's called rotational because you're rotating it around the center to make it match. And it's also called point symmetry because you're rotating it around the center point. Okay. Once again, this shape has a special kind of symmetry, and this symmetry is called rotational symmetry or point symmetry. Well, we'll have angle of, so when you have rotational symmetry, you have something called angle of rotation. And we're going to get into that in a second. Angle of rotation. Well, what is that? So let me give you some more examples of rotational symmetry, okay? From your notes. So this shape also has rotational symmetry. If I make two copies of it, move it, this point will fall onto this point onto this point, and everything will look like identical. Okay, so this has rotational symmetry. It doesn't have, it actually also has line symmetry. I'll show you right now. If you draw a line right through the middle, you can have line symmetry as well. The left hand side and the right hand side, they match. So some shapes have only reflectional symmetry. Some shapes have only rotational symmetry, and some shapes have both. So in this picture, for this picture, we are mostly interested in rotational symmetry. I can show you this one like I did before, why it matches when you rotate it. Let me show you this one. So take a look at the lighter one and the darker one. They're identical. I put one on top of the other and I turn it around the center like a fan, and they do match. Okay. Now, any shape can be rotated a full excuse me, guys. Any shape can be rotated full 360 degrees and it'll match itself. But for rotational symmetry, angle we rotate it around has to be less than 360, okay? 360 is always true. So I don't make a full circle, but this still matches itself. What is that angle of rotation, guys? So what is the smallest angle? I can turn it around so that the shape matches itself. It can be 360 degree. 360 degree is full circle. 360 degrees is full circle. Full circle always works for any shape. That's not interesting enough. So this shape, I can rotate it what angle, guys? Okay, it's really very easy to test, guys. It's gonna be now this angle all the way from here to here is 360. Okay, 360. Now I'm not gonna rotate it 360 degrees. I'll be able to rotate it at a smaller angle, and the shape, the new shape, will still match the old shape. Well, what is that smaller angle? Well, the best way to find it, pretty much the only way to find it, is look at your shape, find the shape center, okay? And then cut the shapes into identical pieces. And how many pieces do you get? Well, you get 5 pieces for this picture. And take your 360, the full circle number, and divide it by 5. 360 divided by 5, which is, let me think, 360 divided by 5. It's going to be 20, 20, 20, 60, 72. It's going to be 72. So if you rotate the shape 72 degrees, okay, you are going to have this shape match itself. Let's do another example. Let's take a look at this one. This shape has rotational symmetry because I can see it. If I take the shape and put it on top of another identical shape and move the top shape like a fan before a full circle, it will match itself several times. What is the smallest angle you can rotate it around so that the shape matches itself? Basically, this should fall here. This should fall here. Well, how many pieces are around the center? Well, there are 8 pieces. I'm just going to label one piece. This is one piece. And there are 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. You're going to take your same 360 degrees, and this time you're going to divide it by 8. And that turns out to be, if I'm not mistaken, 45 degrees. So for this shape, the angle of rotation will be 45 degrees. For the previous shape, it was 72 degrees. So let's pause there just a little bit, see if people have any questions. So let's do a brief summary of what we did. We talked about symmetry. There are 2 types of symmetries. Okay. Number 1 is reflectional or line symmetry. And reflectional or line symmetry has something called lines of symmetry, number of lines of symmetry. Okay. We talked about another symmetry. It's called rotational because you're rotating, rotational or point symmetry. And point symmetry or rotational symmetry is associated with angle of rotation. And we also learned that some shapes only have reflectional symmetry, some shapes only have point symmetry, some shapes have both, and some shapes have neither. That's a basic summary of, we are actually done with that chapter, the last chapter that we were working on, 11.2. It's a section really. So I'm going to pause it just a little bit to see if you have any questions. and we'll do some activities. We'll do some problems. Let me see if I can engage you guys, okay? Give me 1 second. There is a nice activity here. And we'll do some problems from your book. Okay. So take a look, guys. Take a look at the letters of these letters in this font of the English alphabet. And could you tell me now, unmute yourself and please share. I don't make you guys talk too much, but this activity won't work if you guys don't say anything. Can you find some of the letters that have capital letters, this font, that have reflectional symmetry? Anyone? Unmute yourself and let's talk a little bit. Which letters here have reflectional symmetry, guys?
Z does.
Reflectional or rotational?
Well, I thought if you can cut it in half, um,
Yeah.
it would
Let's see.
still be reflectional. You don't have to cut it vertically, you can cut it horizontally.
We have to be a little careful. Let's see. Let's see. Thank you for sharing. All right. So, guys, take Z, the same letter Z, and now if you draw a line like so, if you draw a line like so, now you actually cannot draw a line because they're not mirror image. They are not, you won't be able to fold them and make the top and bottom reflect look exactly the same like their mirror image. If you draw a line like this, you still won't be able to fold the Z letter along the vertical line so that the corresponding parts match like your palm. Or you might say, oh, I'll do it this way. I'll do it this way. And that also won't work. But it does have rotational symmetry. Even if you draw your line like so, if you fold it along this line, if you fold the letter Z, pretend it's a cutout and you fold it, this part will be here, this part will be here, so they won't match. Z has rotational symmetry, but no reflectional symmetry. Let's show you how Z has rotational symmetry. So take this Z, put it on top, rotate it under quarter circle, half circle, and it matches. Okay, so Z is a letter that has no reflectional symmetry, but rotational symmetry. So I would say A has reflectional symmetry. If you draw a line that's vertical, a vertical line, it will cut the letter A so that the left-hand side and the right-hand side are mirror image of each other. Okay. Now, what other examples do we have? Okay, can anybody give us an example of a letter that doesn't have a reflectional or rotational symmetry? A letter here that doesn't have a reflectional or rotational symmetry. What do you think, guys? Anyone?
L.
Good. Very good. One more. Give me one more. There are tons of letters. Give me one letter that doesn't have a reflectional or rotational symmetry. How about F? You cannot draw a line so that the two halves will be mirror image. And F is one such letter. J has neither. Q has neither. E, A, D, C, they have reflectional symmetry. Rotational symmetry, Z is a good example. S is a good example. S doesn't have a reflectional symmetry, but has rotational symmetry. And O, this one is a rectangular O. It's not a perfect circle. But if you had a perfect circle, it will have both rotational and reflectional symmetry. Let's see. So this was a short activity. It works a lot better in class face to face. You can have people talk and they get really excited. But it's a very common activity in your some of you will teach something very similar. And when we do some of the problems from your book, you'll see they have problems just like this. Let's see. Do we have questions on this, guys? Okay, if we don't, this was just a fun example to kind of review your understanding or give you a chance to discuss the two symmetries we talked about. So I'm going to go to the text and do a few problems from 11.2a. That's the goal. And so it's not a bad time, guys, to to jump out and come back. This is going to kick me out in 7 minutes. Why don't we jump out and come back real fast, and we will continue our work. We're not going anywhere, okay? I'm going to jump out and come back in a second. See you soon.